A system is homogeneous if all the solutions are equal to 0. So AX equals 0, where 0 is a vector with all zeros. This is called the zero vector. You should be able to see a solution right away. X equals 0 is a solution. Don't overthink things. Let's do an example. Consider the following system of equations. Notice all the solutions are 0, so this is homogeneous. I'm going to write the matrix A. It's 1, 1, 0, 1, 0, 1, 2, 1, 1. This is just the coefficients of the system. This may not seem like a useful thing at the moment, but I'll come back to it. Write our augmented system and go through the normal row reduction process to get a reduced system. You should practice the row reduction process on this system. Pause the video to do this. You should have noticed that the solutions column were all 0 and never changed. We could have just reduced the matrix A. This will turn out to be a big deal later, actually. The reduced system gives us x1 plus x3 equals 0 and minus x2 plus x3 equals 0, so that x1 equals minus x3 and x2 equals x3. To write the solutions, first write the vector x, which is x1, x2, x3. Substitute it in the pivot equation that we just solved, factor out the free variables, and write for any x3. This last part is necessary because x3 is a free variable, so we need to emphasize that x3 can be anything. This is called parametric form. Notice this is all linear combinations of the vector minus 1, 1, 1. So this is the span of minus 1, 1, 1. Both of these representations are the same. This was fairly simplified since there were only 2 free variables. What if there are more? What if a pivot is equal to 0? Consider the following reduced system. This has 5 total variables and only 2 pivots. First, write the vector x. Replace all the pivots. Separate this vector so that each free variable has its own vector. Factor out the free variable and write for any x3 and x5. Of course, you'll replace this with whatever your free variables are. This could also be written as the span of 3, 0, 1, 0, 0 and minus 6, 0, 0, 7, 1. Notice the parametric form is just all linear combinations of these 2 vectors. That's why it's equal to the span. I highly recommend you try to fully understand this process, especially that last sentence about linear combinations. It will make the rest of this class much easier.